Hello, welcome back, everyone. So, moving to the second and the last panel discussion for today, we are going to discuss methane emissions from solid waste disposal sites, estimation techniques. We'll discuss estimation of methane in Indian perspective, BUR assessment, assessment of different methodologies for methane and their limitations, and followed by that, we will have Q&A. And for this panel discussion, I would like to invite Dr. Sunil Kumar and Dr. Ashutosh Kumar. Please take your chair, sir. I would like to invite Dr. Sunil Kumar to present first. He's a senior researcher cum professor with more than 25 years of experience in leading, supervising, and undertaking research in broader field of environmental engineering and science, with focus on solid and hazardous waste management. Dr. Kumar is a graduate in environmental engineering and management from Indian Institute of Technology, Kharagpur, India. His scientific contributions since inception at CSIR, National Environmental Engineering Research Institute, NEERI, India in 2000 included 272 referred publications, 5 books, 45 book chapters, 15 edited volumes, and numerous projects reports to various government bodies and private, local, and international academic and research organizations. Dr. Kumar was the visiting researcher at United Nations University, Germany, Hong Kong University, Hong Kong, and University of Calgary, Canada. He is the associate editor of various peer-reviewed journals of international repute. Dr. Kumar was also awarded with the most prestigious award, Alexander von Humboldt Senior Researcher Award, for developing a global network and excellence for more advanced research and technology innovation. He has also received EnviroCare Green Award in 2022. Dr. Kumar is also appointed as an honorary adjunct professor at National Institute of Technology, Itanagar, Arunachal Pradesh, and adjunct senior researcher at Tasmania University, Australia. With this, I would like to invite Dr. Kumar on the dais, please.
Thank you, Richa, for your nice introduction. I am still a learner, and I feel honored to be here and to present before Bhism Pitamah of Environment, Professor Asolkar. When I was studying in MTech at IIT Kharagpur, so it was elaborated by my guide, Professor Manas Bandyopadhyay, who is in US right now, and he discussed about this Dr. Anil Agarwal, because I was not knowing anything about environment. Because I entered in MTech program, and I was having interest in structural engineering because I was very good in slope deflection, moment distribution, RCC concrete, and all these things, but I did not compete finally in Indian Engineering Services. I had to move and I have to come in the research field, and then I joined MTech. So first of all, I would like to pay homage to Dr. Anil Agarwal for his contribution in the field of environment, and Honorable Dr. Sunita Narayanji for establishing this institution, with due respect to Honorable Dr. Anil Agarwal. Secondly, I have been working in this field since last 25 years, 23 years at our institution, National Environmental Engineering Institution, and before that I worked for 2 years at Intercontinental Consultants and Technocrats Private Limited, New Delhi, as an environmental and social experts for this strengthening and widening of national highways project across the countries. So 2-3 good projects I have completed on my own, and at that time my mentor was Dr. J.P. Gupta at Intercontinental Consultants and Technocrats Private Limited, who was retired from Ministry of Education. So I learned everything from him, but he was retired from government. So he suggested me, Sunil, why are you working in private organization? You should move it to government. So I was not interested to work for government. I was very happy while working in private. And once the advertisement came, then I came and I worked. So, but one thing, and a funny remarks, I have attended many conferences across the country and in abroad also. I see in most of the environmental conference, the solid waste management research is given at the lowest priority. In this program also, Richa has put researchers in the last panel. I will not go for this making presentation. So I will put some remarks and suggestions for CSE who can put forward before the policy intervention and all these things, so that research can go momentum in this field, particularly this landfill gas monitoring, solid waste, climate change. First project which our institution was assigned by Ministry of Environment and Forest when this NETCOM exercise, National Communication from Environment and Forest, was initiated. And first report that Richa was telling that it was submitted by CSI NIRI to IPCC, this under United Nations Framework Convention on this climate change. So I was given that activity. I was young in 2002 by the then director, Dr. R.N. Singh. And my mentor was Dr. A.V. Sekdar, who taught me all these aspects on solid waste management. So in that activity, we carried out first activity, and it was a very tough challenge to carry out this methane emission measurement from solid waste sector, as the database was very poor. Still, it is very poor. It has not got momentum. If you go to municipality will not give you the data. One of my students is at Lucknow University, Miss Pallavi Singh, and she is going to Municipal Corporation Lucknow, another smart city, since 3-4 months, but she has not got the data till now. I have given data which we have carried, NIRI has carried out long back in 2004 with the instruction from Central Pollution Control Board. At that time, there was a direction from Honorable Supreme Court of India that we have to carry out solid waste quantification and characterization across the 59 cities in this country. And we have carried out that activity. And that was the last activity on nationwide study on solid waste quantification and characterization. And most of the project reports which were prepared by many of the municipal corporations, they took data from our report of 59 cities under JNNU RM activity. So about that IPCC activities, we have carried out first exercise, and for that was the very big exercise. And based on that exercise, we have categorized entire nation on geographical and demographical basis, and conducted primary and secondary data also on quantification and characterization. And methane emission measurement study was also conducted at Okhla Dumpsites, continuous day and night. And at that time, we published 2 papers in atmospheric environment, which was the first paper from our country on methane emission from solid waste dump site. And with the intervention of late Dr. Sekdar, he told Sunil, you first carry out the uncertainty assessment also, because there are a lot of uncertainty in estimation of methane emission from dump site, whether it is activity data or emission factor. So at that time, we adopted this Monte Carlo simulation technique, and we found that around 30%, 38% this uncertainty estimation in methane emission from dump sites. So after that, many studies have been conducted by many researchers across the country, whether it is Manish Chandal from IIT Bombay, whether it is Chandigarh University, Professor Suman from IIT Delhi, Chakma, and Dahiya, and all others, which in a tabular form Richa has presented. And there were many constraints. So it was not easy to carry out the study. So researchers have done a lot of efforts, and we have done good study. Although there are limitations, so it is proposed that CSI should the CSE should interact with MOUD and all other things, and they should emphasize that they should India should carry out extensive, comprehensive study on solid waste quantification, characterization, this methane emission measurement study on long-term basis. As sir is there in US, many of the professors I'm also in touch with many of the researchers in US, whether it is Deborah Reinhardt, whether it is this Maria and all. They are expert in this methane emission measurement. They have done continuous 20 years, 25 years of continuous monitoring. And our country is going to achieve this developed nation by 2047. So we should have also center of excellence on all these aspects, comprising all the researchers at one board, like National Research Foundation has been established by our Honorable Prime Minister, so that all these limitations which have come out in another 5 or 6 years, we should be positive, so we can come out with the good, these default factors for Indian dump sites or other components of the waste management which lead to emission, whether it is transportation, whether it is the storage, other processing aspects and disposal aspects. So we should be positive. Similarly, we have very good operators like Jigma was presenting, Sanjeev ji was presenting, and all other operators are also coming up. So we should encourage them, although there are very loopholes and all these things, but likewise, many people will come up and then we can improve the situation. I was in this one Norway, this consulate general has contacted me just a couple of months back. And she was interested that Norway is going to achieve the circular economy by, they have put some target year. So they have focus on India. India should also achieve, and they would give a study to us, and we will link Indian plastic related company that is only based on plastic waste. So plastic waste organizations, those who are involved, whether it is research and development, whether it is recycler and all other things, they will interact with that Norway waste company, those who are dealing with plastic waste recycling, and they will come and they will tie up and they will initiate activities here also. Likewise, we can achieve the circular economy concept in the country. So other aspects about NETCOM 1, NETCOM 2, NETCOM 3 is going on, all these things. So at that time in NETCOM 1 exercise, we have suggested that default methodology, this modified triangular methodology. Our director at that time, Dr. Devota, who was my PhD supervisor, based on our study, he has written to IPCC. He was a member of IPCC on refrigeration and all other components. IPCC has accepted our findings that default methodology cannot be adopted, particularly for developing countries, because there are a lot of limitations. So then they came out with the land gem methods after our intervention for developing countries. Although there are loopholes because a specific this methane correction factor and this all other factors need to be developed for that country itself, developing countries. Then only we can estimate the actual methane emission. After that, landfill fire, as Jigma was also highlighting, there are a lot of issues. So we have carried out first a study on landfill fire prevention and control with intervention from Department of Science and Technology, Government of India, and surface and subsurface emission. This landfill fire is a very ongoing activities, and all years many of the dump sites are reporting. Like one big fire was reported in Cochin, which our Cochin Pollution Control Board former officer was also discussing just now. Similarly, other in Punjab and other places also it took place. So we have conducted detailed study, and Khandelwal Sahab was one of our external experts, along with Professor Mukesh Khare of IIT Delhi and Professor Mukesh Sharma of IIT Kanpur and other experts, Professor Maya of IIT Bombay. And we have carried out the study, and the report we have submitted to Department of Science and Technology. And based on that study, we have come out with 2-3 major findings. First one is prevention, how we can prevent landfill fire. That for that we have to go for this hotspot identification, and then we have to put like thermal sensor, and we have developed a rod also which enabled with this thermal sensor and all other things, and quantification and characterization, all these things. And we have come out with patent also. We have one of our PhD students, Digambar Chauhan, who has done all this exercise, and Deval Singh, he is pursuing PhD at IIT Bombay. So that patent is also under process. And third is this control. So due to landfill fire, a lot of methane is emitted. How we can oxidize it to carbon dioxide? For that, we have come out with detailed bio-cover design. And for that, this bio-cover design patent has also been filed. And we are in the process of establishing 2-3 system at couple of dump sites, and we are in touch with DST is going to fund. And Dr. Bharat Sharma has joined Central Pollution Control Board member secretary. He has also agreed. And Punjab Pollution Control Board chairman, Professor Big, he is also interested. He's identifying one dump site. And with all the 3-4 partners, we are going to establish all these aspects, prevention and control aspects at the dump site across the country, so that it can be replicated throughout the country. So these 2 aspects I would like to highlight about model I have told. And based on that, this CSE can intervene towards policy intervention through Ministry of Urban Development as well as Ministry of Surface Transport. And last but not the least, there are many, I found that there are many questions from online participant also, and I think nobody is addressing those questions. So we should come out with all those questions and then we should give reply. Thank you very much for your kind and patience hearing.
Now I would like to invite Dr. Ashutosh Kumar, our next
Richa,
speaker.
can we just check whether there is any question for Dr. Sunil Kumar?
Okay. So
Any quick question for Dr. Kumar, anyone?
maybe what we can do is we can invite Dr. Ashutosh Kumar first, and then we can, after his session, we can ask,
Okay.
like whatever is convenient.
Fine, no problem. Carry on. You can take questions at the end of
Yes,
Dr.
yes.
Kumar's presentation.
Because the topics are going to be very much
Yeah,
similar.
yeah, okay.
So Dr. Ashutosh Kumar is an eminent scholar and enthusiastic researcher with a focus on environmental science and engineering. His pioneering research revolves around sustainable waste management, advanced oxidation processes, and air quality dispersion modeling. Throughout his illustrious career, Dr. Ashutosh has published over 16 groundbreaking scientific papers, which have garnered more than 1,000 citations from fellow researchers, highlighting their significant impact on the ground. Driven by his passion to make a positive impact on the environment, he earned a PhD degree in environmental engineering discipline from Hong Kong University of Science and Technology, and MTech degree in environmental management of rivers and lakes from IIT Roorkee. In recognition of his outstanding academic achievements, he was honored with the highly competitive and prestigious Hong Kong PhD Fellowship Scheme Award in 2015. Following the successful completion of his PhD, Dr. Kumar joined as an assistant professor at School of Energy and Environment, Thapar Institute of Engineering and Technology, Patiala. With this, I'd like to invite Dr. Kumar on the stage.
Thank you very much, Dr. Richa, for the nice introduction. So first of all, I would like to thank the CSE, especially Dr. Richa, Dr. Atin, for inviting me here and giving me this opportunity to talk about this burning issue. Because as Dr. Sunil said, we basically very less talk about this important topic in the environmental conferences and all. So before starting this, let me make few points here regarding the morning session. I was listening to Professor Asolekar. I was listening to Dr. Richa. So I would like to highlight some key points, like why actually it was coming to my mind, why we have gathered here. So I could see in the presentation of Professor Asolekar, there was one data. It was showing if we take the cumulative waste disposal rate of rural and urban area, India, then we can see there is a small gap, but still the rural India has the upper hand. But in the next slide, I could see if we talk about the per capita disposal rate of solid waste in India, And then we compare about the rural and urban India. Then the urban India is having at the higher end, and it is the gap is very high, very huge, I must say. Similarly, if we talk about the developed world and developing countries like India, then if we talk about the Western world, their waste disposal rate is around 2.5 kg per capita per day. But in India, it is around 500 grams per capita per day. So basically, we have the 5 difference. So now the question is, actually, we also say like, make the people educated, make the people sensitized about this important topic. Then probably people will learn we should not dispose the waste like that. But the data is saying something otherwise. Actually, we are going in different direction. So I am putting this question to the audience. Let us think about, because we assume that in rural India, people are not much educated, or you can say some people are illiterate, but you could see the difference from rural to urban India. Similarly, from developed to developing world. Also, we can see the huge difference. So the question is whether the problem is the education or the problem are the educated people. That we need to think about. That question, I leave it up to you. I am not going to answer that question. Now, since morning, we are talking about data, like we have actually gap. We don't have particular kind of data. We don't have real time of data. So there the role of modeling do come. If you don't have, continuous data, then how you can simulate the things in real time. So actually that is there the role of modeling do come. So let me talk about influence of data processing on methane estimation methodologies. So this is the actually same kind of information what Richa presented today, and it is also printed in the booklet I was observing. So let me quickly just go through this slide. So here Dr. Sunil also said like default method was the first one, then they came up with the modified triangular method. So I would not say which method is right or which method is wrong. I actually see this methodology in progression, in continuity. Like we came up with the default method, we had some fault, then we came up with the modified triangular, then first order decay. Thereafter, similarly at the same time, US EPA also actually came up with the LandGem model. So I will also show some of the study of this field, which is actually based on all these models, and I have compared many kind of study. And I forgot to mention in the beginning that how this study I started. Basically, I was the master student at IIT Roorkee at that time. Then my guide assigned this topic to work on in the second year of MTech project. Then I was doing research. Then I have came across a paper of Dr. Sunil, who is present here, and even Professor Asolekar, few papers as well in this area. So that is how this study started. So I'd like to see these people are pioneer in this field. So let me talk about the first order and landfill gas emission model in the coming slide. So this is about the basics of the LandGem, because just when we start talking about the modeling, people do think that it is very complicated thing. So let me tell you, it's not complicated. It's a very simple thing. It's a simple model. It's a freeware, right? It is based on the Microsoft Excel interface. So that is how this model do look like. So here real problem is the model parameters, like you can say methane generation rate. So most of the time we take about the default parameters, like what is recommended by the US EPA on which kind of climatic condition as per the US conditions. So in the previous session, most of the speakers talked about that also. But what I did in my study, actually, I designed the parameters on the basis of data available in the Indian condition. Then I didn't took the default actually parameters. I took the empirical data and I did my study. So these are the prominent parameters. Actually, let's talk about the moisture content. It plays a big role. Like if you take more moisture content, then of course, the methane generation would be very high. But at the same time, you are also miscalculating the thing because moisture has also certain weight, right? So in the morning session, the speaker also highlighted this problem about the moisture content. And then we have methane generation rate, characteristics of waste, like waste characteristic means what percentage of what kind of matter is there, whether it is biodegradable, non-biodegradable, inert, those kind of things. Then important thing was highlighted before also, quantity of waste being dumped because we don't have proper data. So here basically I did a kind of comparative study of all the previous study done at that time. Actually, this study was done around 9 to 10 years ago, which I am presenting right now. So in the first study, you can see the ultimate methane yield is different. But why it is different? Because the authors actually considered the waste characteristics what was present in the Delhi. But the thing is that if you are going to suppose install a waste to energy plant, then you should not consider the data which is actually available in the city of Delhi. You should consider what are the data available at that site, like what are the composition in the landfill, right? Because we are going to install waste to energy plant there. So I also found a report of Delhi Municipal Corporation, which actually on that basis, basically, I determined these factors for these 3 dumping sites of Delhi. And here what I found was that actually they assessed that 10% are the wood material, right? In the municipal solid waste of Delhi, which is actually picked by the rag pickers. So that 10% was in excess. So that I reduced. So that is how these figures came. I am actually explaining this in nutshell. And you can find there are studies which are cited below in these both tables. Based on that, I considered 3 case studies, case A, B, and C. So case A is done by me, case B is also, but it is kind of overestimation, you can see. And case C is also there, which is done by US EPA. So basically, I have compared all the methods on the basis of data available and previously reported in the literature. Then I compared, you can see the case 1, which I accounted. It is very close to the in situ chamber method. Means actually in situ chamber method is a kind of practical method, like they go to the landfill site and they measure how much methane is getting emitted. So like we say modeling has also some issue, that practical thing is also having some issue. They also cannot report the thing happening in real time, right? So there could be some plus minus everywhere. So the point is that the data I am reporting, it is very close to the real-time data. If you can see the other data like 17, 13.7, it's kind of overestimation, far overestimation, I would say. Then one more thing is here, if you compare the first order decay model method there, the data is coming 13.3, here also it's coming 13.3. So they calculated from the first order decay method. I calculated the same thing from the land gem model. So point is that both model are the same. It's about the user interface and all, because the basic chemical reaction is same there. They also adopt the first order decay method in the land gem also. So the point is that any methodology out of FOD or land gem you can adopt. It does not make any difference. The difference is the input parameter. So now the question come like Richa met in the last conference, and there also it was a big gap, like how much landfill gas we can recover. So actually 10 years ago, I did this study with the help of literature published by NERI, and they suggested around 25% of the landfill gas we can recover out of the whatever landfill gas is produced. And I guess nobody is from re-sustainability here. So actually the picture he was showing in the Hyderabad, I was also involved in making that landfill. Just after the master, I joined Hyderabad Metropolitan Development Authority. That landfill site, it was being constructed at that time. So that plant is, I guess, consultant is the Atmos Power for that plant, right? I guess you must be aware of. No? Okay. So Atmos Power. So he met in the previous conference, which I was also there. So point is that why I am discussing, because this thing I have reported 10 years ago, he also reported the same thing, because we asked that question and he said it is 20%. We are able to recover. So now point is that we should publish some data, like the company like Sustainability should produce at least something. Like we cannot just rely on one data. We should have set of data, then we can have debate, then we can go further and we can say, okay, which is right and how, which is wrong and how, those kind of things. So I request him, if he is listening, he should actually produce certain data so that public should be aware how much we can really recover. Then this is a new approach of quantification of municipal solid waste in from the tourism waste in Himachal Pradesh. Why I am presenting here? Because waste accounting is very important. Like when we don't have any real-time data, like government agencies are also facing certain problem, like they also require a lot of resources and money to conduct this kind of study. So this study has never done it before, any part of the world. So I tried to formalize a methodology which can account the tourism waste. So here there are two parts. One part is the data collection and another part is the data analysis. So in data collection part, basically we have collected how many foreign tourists are going to the Himachal Pradesh, how many domestics are there, how many days they are staying, and how much they are waste producing, and how much that part of the waste is collected by the urban local bodies. Other than that, we try to establish that correlation, and I also find out that education is not going to affect waste generation rate. It is very poorly correlated with the population. But number of tourists and GDP spent on the tourism related activity, that is going to actually affect the waste generation rate. Thereafter, taking all this data and linking with the economic activity of that particular tourism related activity, I applied this GWR analysis, actually geographic weighted regression and multicollinearity test. After that, I came up with this result, like how much waste would be accumulated. I call it right now neglected tourism waste, like which is outside the boundary of urban local bodies. Outside the boundary means 30 kilometers away from the area of ULB, because in India, on the paper, it is like urban local bodies can collect up to the 30 kilometer of the boundary of their municipality. So that is how I came up with this result. And these are the two publications I published during my master's, published in Sustainable Energy Technologies Assessment, most of the part in this presentation from there, and another one from Urban Climate. And this is my recent study of the tourism waste published in Waste Management. So this is all about the research. Let's talk about the challenges, because the theme of this conclave is challenges and opportunity. So I have shown some opportunity before. Now let's come on the challenging part. So first is country-specific methane generation potential for various components of the municipal solid waste. Like previous speakers also highlighted, we don't have data on the Asian country, we have for the US or European country. So that data we should have, then only we can do more refined work. Then another one is the inclusion of variation in L0, that is methane generation potential and K value. It depends on moisture content. It also depends on the rain happening throughout the year, how much it is happening. Like in the study published in Urban Climate, I reported Mumbai is having the highest methane generation rate. That is due to the rainfall, because I had some empirical relationship there. That is how I calculated. Then third is the inclusion of variation in waste composition over time. This is very important, because this year or maybe today we have this much composition, maybe tomorrow we have big composition. So these things are also not included. So these are the challenges ahead we should include. And this is information about me. If you want to write, you can note my email or phone. Thank you.
Thank you so much, both of you, for the very insightful and informative session. Now we will open the session for Q&A. Do we have questions for the panelists?
Hello, sir. So firstly, it was a well presented one, both of you. Firstly, I want to answer Ashutosh sir's question in the starting that you asked, is it the problem of the educated or the uneducated? I would say it's the problem of the ignorance in the people that's causing it. Now coming, I have two questions. The first one is, in one of the slides that you showed, which presented different methods, that is in situ chamber method, the default first order, or the modified triangular method, the in situ value was nearly 4.6 and the other values were like 10 or above, literally more than double of it. So what is making the huge gap between the in situ versus the other methods, sir? And
Actually, one thing I actually in the last slide I presented about the waste composition, because we are calculating the thing about 20 years back, and the in situ chamber method, they just did the study for 1 year. So you do not know that year what kind of composition, actually what kind of degradation had happened, not the composition, and then how much methane is generated. Another factor is, like through that method, it's not possible that all of the methane they could have captured. Maybe some could have migrated, right? So that is how you can say. And in another way, you can also say that some of the model studies are overestimated. So both actually in situ as well as other methods should actually come down and follow a middle path, I must say.
thank you, sir. I could say this is a generalized question, but since both of the panelists are researchers and I being a student representative out here, it's even sir also stated in the starting that it's the, even to start a research of a comparison or an analysis between the ground data and the reports or something, we always face this problem of there's a lack of data availability, there is discrepancy in this. We always go on the blaming side. So I really want to know what are the solutions or suggestions that you being the researchers and having the experience over the years would provide to fill this gap.
Thank you very much for your question. For any research data, if data gap is there, so you have to see how much data is available. And then we have to interpolate, extrapolate based on the situation. Like in solid waste case, we have extrapolated many of the data, like where Okhla dump site data was available.
Sir, your voice is it on?
For Okhla dump site, we have estimated and we have measured value also. But that dump site, this historical details of Okhla dump site were not available. Only for a few years it was available. So we have extrapolated based on GDP and what are the informations available about that site. We have extrapolated for 20 years back. So we have to perform that activity according to that.
So basically, modeling gives you the liberty to extrapolate and interpolate data, provided that you should specifically mention what are your assumptions, how did you arrive at this value. And I think in peer-reviewed international journals, it is also required to give supplementary material. And please correct me if I'm wrong. We do that just to make sure that the reader who is reading it should understand that these values are not from the ground, taken from the ground, but we have limited data sets and we have done some sort of extrapolation. And
Let me first answer the Dr. Richa question. So basically, wherever we are doing the extrapolation or interpolation, basically I didn't do, but researchers do actually. But I'm not saying it's wrong. What I am saying that researchers are filling the gap where you don't have anything. They are showing you the hope that this can be done and this can happen like this. And then I would like to answer her question. So you are asking about the secondary data, right? So point is that all of my 3 research papers are not based on the data collected by me. I collected the data from the literature. It is all secondary data. And all are not the review article. These all are original research articles in very reputed journals. So that first prove that, like if you have better data analysis, like sir has said, you need to find that gap, right? Then you need to fill that gap from your perspective. I mean, supported by the literature. Then you can do that thing done. Did I answer your question? Thank
Ashutosh ji, she asked about in situ measurement of methane. Could you please elaborate little about it? And I believe that, let's say if I have a monitoring device, so our team has purchased a monitoring device.
Actually, this study is done by IIT Delhi, and paper I have quoted. So probably, I guess, Professor Dahiya or someone is there in that paper. I don't know whether he's from IIT Delhi.
Kavita thi. I think that was done by Kavita, PhD student long back, and Dahiya was also there. So in situ measurement and modeling, in situ measurement, like we have carried out flux box study at many of the dump sites. Also this agricultural field, Dr. Chamendra Sharma was there in National Physical Laboratory. Unfortunately, he passed away last year. So he has carried out that study, flux box study, based on the suggestions by expert members, which were chaired by Professor A.P. Mitra, who was the climate change experts of our country. So based on that, we have conducted flux box study, but that was also, there were a lot of assumptions, because it was done for this per meter square per hour and all this study, and we have to predict it for entire dump sites and then predict it for in the entire country for all the dump sites. So there were a lot of assumptions. Based on that, it was differing.
Yeah, so I think this is the answer of your question. When
That Kshemendra Sharma paper is also cited in that study. So you can go into that paper and you will find a lot of cross-referencing. Then I guess you will learn more about that in situ.
Just this summer internship was at University of Waterloo, where the Canadians or the Waterloo basically uses this chamber method. So when I was a part of assessing the carbon fluxes using the closed chamber methods, and my professor or the supervisor was Maria Strack, who works on all of these wetlands. And even for the landfills, they were working with the same chamber method and they use the same data, but they also model it with those correction method of R and things. So that's why I was confused. Like over there, I saw majority of the people, like, even over there, obviously we choose plots based on different analysis, and we cover it to the whole area of research based on the plot result data. But when I saw this, it's like there was a huge gap between the in situ chamber method versus the modeling thing, whereas over there, they base most of their studies and reports based on those in situ measurements itself. So that's how
I think you have done it at Waterloo, so you must have heard about Professor Patrick Hetiarchi of University of Calgary. He was behind that exercise.
Thank
you. No, I would like to add only two things. Whatever the feasibility of methane emission, I did a study for, I got done a study for all the 3 landfills, and what has actually produced, that too, I have got it done for 5 years. So I can share both the reports tomorrow.
Thank you. Thank you.
Both the reports.
Thank you very much.
Which are,
and whoever is interested in this area, I would also suggest to actually study the reports produced by GAIL. I guess, sir, you were part of that team, right?
No, that
GAIL India.
GAIL report of
on Mumbai Deonar landfill site, as well as, okay, you were there.
Yeah, I am.
So somebody told me in the last conference that report is taken back from the internet.
No. I have both the reports with me.
Okay.
So I will share with you. So,
please share.
The estimation of the methane in the existing landfills and extraction of methane from the existing landfills. I have both the reports. Thank you. Estimated was higher. Actually, extraction. You people can do it.
Sir,
I'm the field engineer.
Sir, I would like to explain about that Gorey dump site, because we have carried out one study from US EPA, but that Gorey dump site. So whatever estimation we have done it was done it based on default methodology. So that overestimated the methane production and emission. But when actual this extraction was done, it was very low. It was very low. That's why it did not sustain. It was closed. City.
But sir, isn't it confusing? Because when we say that the methane potential is this much, people think that let us extract it, cover it and extract it. But they should understand that the amount of methane that they're going to extract is just 15-20% of what has been estimated by using a model or by in situ measurements.
Right.
Yeah.
The estimation as well as the extraction was the same. The only issue is we did part closure of the landfill, so we could not extract properly, and there was some ingress of oxygen and all those things.
You mean post closure?
Yeah, post closure is a part. We did part closure of the landfill.
No, Ashutosh, this emission and extraction for a few years it came, but it was not sustained because potential was very less. So emission potential estimated was overestimated. That did not fulfill.
I would like to add something what Professor Sunil has said about the default method. I would like to add something. Why it is overestimation, the default method? Because they follow the zero order kinetics, right? But in fact, biological reactions are either first order kinetics or pseudo first order, right? So that is how overestimation was there in case of default method.
Since I am getting attention of Professor Sunil Kumar, I would like to get more clarification on this matter. So I will not hold you guilty if you tell me so much more is the estimated potential of the landfill. Because at that point, you are only considering the known kinetics, number one, not having too much of impact of temperature on the kinetic rate. You know very little about how much moisture will be there in reality. You're assuming some kind of ideal moisture, which statistically you think is ideal. And then fourth thing is that you are assuming so much of waste coming there, which may or may not come for so many other reasons. That's separation at source or whatever. So because you are working with so many you are ignorant about reality in simple words, and which you are not guilty for being ignorant because everybody is ignorant about future reality. So therefore your estimate is going to be more. And because you are using thermodynamic limits without considering kinetic impediments, your answers are going to be much fatter than reality. But how much is this different depending on how you guys consider as the potential of methane, considering or not considering certain reality perturbations? How bad are you or how good are you in terms of potential versus extracted? Because one more, Professor Sunil Kumar, one more thing is not known to you, that how much you are not able to capture. So that is a very big if, and that is a very big gap actually in the knowledge. So considering all this put together, then how good or how bad are you? But I think he has some comment to make. You listen to that and answer that, give your expert opinion.
Another is the potential of extraction will depend how you are extracting. Because these are not engineered landfill. So there's system, because when we were doing the boring, a big stone has come. So we will not be able to bore properly up to the required depth. So these are some physical site difficulties are also there. So proper extraction system is also important for efficiency.
I will have one comment on the side after. Yes, sir. Thank you. I already explained in my presentation that many assumptions were made in estimation of methane emission from dump sites. And to support that, we have carried out uncertainty estimation. How much uncertainty is associated in methane emission from dump sites, inactivity data as well as emission factor. Say it once again, not here. Say it once again. We have estimated uncertainty. How much uncertainty is there? So in some cases, we have found it is more than 38%. Some cases it was 25%. So it varied from site to site. So that may be the reason. That's why we have estimated uncertainty and the statistical evaluation. From site to site, it varied.
But in my case, the estimation is also in situ and the extraction is also in situ.
Oh, I think that is the real riddle actually. Because but Agarwal sir, Agnihotri sir, you are playing a blind game. The problem is this: what basis do you have? What understanding do you have about hind casting of the waste? Where is somebody doing any intelligent work on hind casting? So obviously you are only multiplying numbers. So you are spreading your ignorance very thinly and uniformly. And now you pat your back saying that you are very uniform and you are very upfront about it. But what do you have in the basis? Mudal mein kya hai? Batch ke baat chal rahi hai. You're talking about interest. But there is you are not very sure about what is the principal component in the whole calculation. Now you're applying your factors very intelligently. So hind casting is, Kumar Sahab, is the basis of really able to say something about what is the potential. And I think that is the real unknown thing. He getting one boulder is a very small issue in my opinion. If he drills 10 times, he'll get 10 boulders. But even if he knows the size of the boulder, still he is at zero level because you do not have any model for hind casting. That is the real crux of the matter in my opinion. And then putting all ideal factors on top of it, you are going to give a very fat number, how much methane is coming. So there is all the way a good case of putting a cap. Maybe it will cost 180 crore rupees to put a cap, but you can pat your back saying that so much of methane is going to come. These are the issues. So scientific uncertainties are making look your project very viable. Whereas you are not counting the dangers of your ignorance and your inability to go in the past and declare the data. I think that is where the big crack is there. And all the water in the tank, you construct a beautiful tank, but when you open the lid, there is no water in it. That's the whole problem. Sir, you want to say something? With suggestion from Professor Asolkar Sahab, I think there are a lot of research and development opportunities for young people. With many young people are here. So there are many young opportunities for research and development.
Actually, I have a question and basically builds on that actually. So on the data aspect, we mentioned about the challenges in data, like the variation and the composition. So I think the 2004 NERI have actually supported a lot of researcher and policy. Are there like future plans of some similar study, a national level study, or can we also leverage the data that is being generated through like search surveillance and other national programs?
Yes, sir. Thank you. I think around 2016 when Dr. Vate was our director and Mr. Chaurasia was this advisor in charge of Ministry of Urban Development. I have prepared a proposal for around 125 cities for this waste management data generation, but that was not formalized. This just I came to a study about there is a program of E3OW, this Earth, Environment and Atmospheric Sciences of CSIR has mega program, different thing. Under energy and environment, CSIR has come out with mega funding on research project. And in that projects, I have seen a study that Simeri Durgapur has sent that call for proposal. So our director is the in charge, Dr. N. Vaidya. So he has formulated data generation aspects as per the requirement of IPCC for waste management, including municipal and hazardous waste. So a lot of programs under the theme category like DRDO was carrying out. So CSIR is also coming out under different theme like in climate change. Last year, that program was initiated by CSIR. I think 200, 300 crore projects have been running, started, formulated. Similarly, for E3OW, new project is coming up. So there are many opportunities for that department also. I think this urban development must also have to come out with different strategy, and National Research Foundation has been set up. So many programs will be coming up.
So I don't think we have any more questions, and this brings us to the, yes, sir. Yes, sir.
See, the real question is, so can you really in real life, with so much of uncertainty about your own basic data and many such wide gaps, Sunil Kumar Saab, in your understanding, not your mind also and everybody's understanding, and very barely a scientific method has been used for methane generation and methane potential, can you really make rationally a project proposal where you can claim that this is viable and public money should be put in methane exploitation? I'm asking a very basic question, Atim. And I really, if somebody comes to me, and if you make me commissioner or you make me some officer in municipal corporation or ministry or CPCB, I'll say my vote is not there. If somebody is quite enthusiastic and want to put his or her money and try his or her luck, because some Norwegian, because some Switzerland person is saying, congratulations, please try it. It is your luck and be my guest for it. But I will not be very much comfortable putting public money for this work. This is my take. I may be wrong, and I have been many times wrong, I think.
There is nothing right or wrong.
I have been many times wrong. But my heart I am pouring in front of you. I will not say that this is an intelligent idea to put a public money on a project where scientists are admitting, and I'm 64-year-old, you do not know how little I know about what happens in landfill. And there is hardly any data about Indian condition. And the variability in India is 3 degrees centigrade to 46 degrees centigrade. You know more than me, you are from Nagpur. So we know what kind of variability of temperature is there and what is going to be there. When we are saying, Atim, 38% moisture is required in the waste, how many days 38% moisture will remain, Richa, in when you distribute wet solid waste in the landfill? I would like to know really any wild guess. I put my name and money on it. It cannot be more than a week, and it will become a non-viable moisture content in the layer where very rich material is there which can generate methane. But methane will not come out of it because you will not have a moisture to start with, which is the starter for the methanogenic reaction. How much water is required for methanogenic reaction? See, if you take, I don't know, I mean, so many things, you should have a scientific summit now, Atin, because the whole problem is when you are saying, Richa, you are showing the anaerobic reaction. What is the percent water required for conducting an ideal biological reaction in anaerobic condition in a controlled chemostat in laboratory? You cannot take a wastewater, or you cannot take the slurry coming from sugar industry, which is molasses, which is called as, which is the mother for creating so much of methane.
Correct.
And then making sugar industry is viable, and then also go in alcohol way, and the dream of fulfilling so many percent of alcohol, I mean, into the blending it into the fuel. We are failing because one of the impediments is not non-availability of water. Where will you put water to dilute it? Anybody here? Anybody who here is a trained microbiologist? Anybody raise hands. How many is a trained microbiologist? I put my name on it. You have to put water in molasses to create methane, Richa. So you are telling me that methanogenesis will happen in a solid way where 38% is the highest moisture content, and you are wishing that it will remain? I can't imagine how can methane come out of Indian condition. Until you take me to Jammu Kashmir, where there is beautiful and weather, and then temperature is low enough so that moisture will be retained, and you are talking about 15 years of gas coming out. I think either we are poets or we are extremely hopeful. I am not, at my age 64, I am not that hopelessly romantic. I am not. Please. I'm done. We have a lot of waste. So
basically what happens with the organic waste in the contact of the air due to degradation, biological degradation, lot of water is also produced, carbon dioxide is produced, so that keeps trickling down to the bottom. So look at the area and the exposure. The moment the waste is dumped, because I have worked on the landfills when it is dumped, because I did two landfill wells in Motijil area in Lucknow in way back in 94. So that yeah. Sir, what I am talking on the surface, organic matter up to 1 meter, it is continuously degrading.
Okay, so what is good to see that even after almost 6 hours of intense discussion, the energy level looking at Asoleka sir, Agnihotri sir, and all the other panel is so high. I'm sure by now 8 hours. Sir, we started at 10:30, sir. We started at 10:30. Yeah, almost. So, and then we had a lunch break of 1 hour. My math is still not that bad. Anyway, so I'm sure all our brains are by now full of methane and legacy waste and whatever rest coming out of a dump site. But I mean, I couldn't thank enough to all the panelists, Dr. Richa Solekar sir, Secretary, Government of UP, Sunita ji, for contributing to an agenda that needs much more attention than what it is receiving right now. So the whole objective, we have been writing on all social media platforms. I hope I was told that there are people in all social media platforms that are connected to us. I can see at least 26 people are connected to directly Zoom who are listening to us throughout the day. So the need of the hour is to make it an agenda. We need to understand that here is a resource which we are losing day in and day out. And then it is contributing to global warming and every other environmental challenges that we are not being able to deal with, right? Dump site remediation is a distant dream, according to my understanding. During the discussion that Nagesh and Sanjeev ji contributed, Sanjeev ji specifically pointed out that waste to energy is doing good in our country, right? I wish that was true, right? But in CSE, we have a culture of not saying things unless we have evidence. So we have started collecting evidence, right? The truth of waste to energy is very different from the way it is presented to us as a one-stop solution to all waste problems. It is not as rosy as it looks like, right? If you are allowed to enter in a plant, waste to energy, any functional plant, my best wishes to you, if you can at least pull it off and get that permission from the authorities. And there are reasons why these permissions are very difficult to get, right? But all of us are entitled to have an opinion, right? And we must also agree to disagree. That's end of the day, that is the spirit. We all come from different sector, we come different experiences, but end of the day, what matters is that we collectively are contributing to an agenda. So on that note, let us close for the day. I saw few hands who are, if they are still interested, to go to the lab and take a quick look, because tomorrow the window is very little, because we have to close by lunch and there are specific travel plan, flight schedules, which I have seen. So that doesn't give us any avenue tomorrow in the morning to do the lab walk around. I was told that there are few people, basically we're also having a training parallelly going on in the lab. So they're still in the lab, but there are 3 different sections. So we can start with one. And then by the time we get to the section where the students are working, probably that will be vacated. One good news is that we can get rid of the methane that we have accumulated throughout the day, through all these discussions. We have organized a small get-together in the lawn with some Rajasthani delicacy. It's not a street food because everything is going to be cooked here. And in terms of food, we do take utmost care and sincerity. All the cooks are very well trained. So we'll expect all of you to be there in the lawn between 7:32, but that's not dinner, let me remind you. The dinner is separate. So leave some room in your stomach to have dinner separately, maybe at 8:30, 8:45. So 8:30 we'll start serving dinner. So that's it. Richard, did I miss anything? All right, sir.